Electricity plays a vital and ever-increasing role in modern commercial nurseries. In order to keep up with consumer demand and innovations in the horticulture industry, nurserymen are turning to electricity as a clean, fast and cost-efficient fuel. The versatility of electric energy is clearly demonstrated in nurseries as it is used for mist propagation, irrigation, steam sterilization, heating and environment control. At Delta Nurseries, located on the Gold Coast, owner Neville Raywood has built up a large and thriving business in a very short time. Neville has combined his skill as a horticulturalist with astute use of electricity to come up with a winning formula. At present, the nursery itself occupies 1 hectare. The total number of plants under controlled environment is approximately 250,000 at any one time. Delta Nurseries make extensive use of mist propagation. Many plants which are difficult to propagate by other methods are successfully propagated using the mist propagation system. The misting jets operate under a pressure of 420 kilopascals. Each spray has an output of about half a litre per minute. This method allows the operator to program ideal conditions for the plants. The controls for the misting jets are located close by and can be manually overridden if necessary. The thermostat control for the mist propagation is of the bulb type and is placed in the plant beds for accuracy of control. Floor space in a greenhouse is always in demand, so when the misting sprays are not required, they can be quickly detached and stored on the wall. This space is then utilized for other purposes. The nursery business is a very competitive one. Plants must be available at all times and availability should not be dictated by seasonal trends. Because of this situation, it is important to provide a suitable environment for plants to grow in. Without adequate control systems, the environment in a greenhouse can fluctuate widely. There can be extremes totally unsuitable for plant growth or propagation. The environment control in a greenhouse is designed to even out the extremes of the environment rather than provide constant, unvarying conditions. Delta Nurseries have installed 300 kilowatts of electric greenhouse heating, combined with fan-forced ventilation systems. This installation was designed by Sequeb technical advisory staff in consultation with Neville Raywood. The heating system is controlled by simple and reliable electric thermostats. The fans at Delta Nurseries perform double duty: warm air distribution for heating in cold periods and ventilation and air circulation for cooling the greenhouse in hot weather. Air is distributed throughout the greenhouse through polythene film ducts. Outlet holes are cut at regular intervals along the air ducts to distribute the air evenly throughout the greenhouse. Minimum and maximum thermometers are placed in the greenhouse to record temperature extremes. To achieve accurate soil temperatures, Neville uses electric heating cables on propagation benches in this greenhouse. Speeding and routing is obtained with most cuttings by the application of bottom heat, easily applied using electricity. Propagation is possible over a longer period of the year. The electric heating cables run underneath the elevated benches of plants. Here, electricity helps to provide a controlled flow of fertilizer to the nursery. The fertilizer injection pump automatically adds fertilizer to the irrigation water for optimum growth rates of plants. A concentrated fertilizer solution is held in a 200-litre holding tank. A stirrer ensures all the fertilizer is dissolved. When irrigation commences, a contact head water meter governs the operation of the injection pump to add fertilizer to the water. The control system adjusts automatically to varying flow rates to achieve a constant fertilizer concentration in the irrigation water. To ensure an adequate supply of electricity to Ian Raywood's nursery at Labrador, a ground-mounted transformer was installed. Heating of the nursery is provided by two 200-kilowatt inline electric water circulation heaters. These heaters operate on low-cost electricity. Electric motor-driven pumps circulate water over heating elements. Hot water is then circulated through finned coil water-to-air heat exchange units. Fans draw air through the heat exchanger. A temperature sensor located among the plants gives precise temperature control. Since this system has been installed, the owners have established that electric power provides the most economical form of energy for their operations. Progress Plants, another rapidly expanding nursery, is installing a greenhouse heating system with a difference. This system will have the advantage of using off-peak electricity. Sequeb engineers studied the needs of this nursery in conjunction with the owners. A system was designed to provide the necessary requirements of the nursery at an economical price. A 22,000-litre concrete tank is used to store hot water at temperatures up to 80 degrees Celsius. This water is heated between the hours of 11 p.m. and 7 a.m. using electric power at a special low off-peak rate. An electric motor-driven pump will circulate water from the storage tank through these three 93-kilowatt electric heaters during the off-peak period to heat the water in the tank. When completed, the tank will be insulated to minimize heat losses. When heating of the greenhouse is required, a second pump will circulate hot water from the storage tank through finned coil water-to-air heat exchanger units. Fans draw air through the heat exchangers and deliver warm air to the greenhouse through polythene film ducts. Each fan is driven by a 1.5 kilowatt three-phase motor and will deliver 340 cubic meters of air per minute. The electronic heat control system ensures just the right amount of heat energy is transferred from the hot water storage tank to the greenhouse atmosphere to maintain the required temperature. Using the low-cost tariff, this procedure provides consistent greenhouse heating at an economical rate. Frank Hart's nursery at Rochdale uses 360 kilowatts of electric heating in one greenhouse. The heating system is efficiently and effectively controlled by low-cost thermostats mounted close to the air intake point of the heater fans. The large axial flow fans draw the coldest air in the greenhouse from floor level and warm the air by circulation through electric elements mounted in the air duct system. 4 heating units distribute warm air in the greenhouse through air ducts. These air ducts run the length of the greenhouse, a distance of 90 meters. Air discharge holes are located along the ducts to evenly distribute the warm air to the greenhouse. The battery electric vehicle is an integral part of Frank Hart's nursery. It's used to carry plants and equipment. Pollution-free, it is reliable, silent and convenient. The vehicle's batteries are recharged overnight by a charger plugged into a power point. Abundant water and electric power provide the ideal combination for a nursery. Here, irrigation water is provided by a 15 kilowatt electric motor driving a centrifugal pump. Washable filters remove unwanted materials from the water, preventing the blockage of sprinklers. This outside shade area is serviced by an automatic sprinkler system. These Moss sprinklers operate at 300 kilopascals pressure with a water output of 8 litres per minute. They deliver a fine spray which does not damage the plants. The irrigation sprays have a 10-metre diameter of coverage. They're arranged in an overlapping pattern to ensure even coverage for all plants. An automatic controller activates the irrigation pumps. This controller operates 10 watering stations in sections of the nursery. The irrigation controller is programmed to operate on the desired days of the week, time of day and areas to be irrigated. The controller irrigates one station at a time in sequence to water all sections of the nursery. The correct market timing and quality of cut flower crops often depends on day length control. The day length is controlled using artificial lighting and blackout curtains to turn night into day or day into night. Richard and Robert Tomasewski supply carnations and chrysanthemums to Brisbane and interstate markets. It is vitally important for them to be able to provide quality flowers at the market peaks of the year. The chrysanthemum is a short day plant and will not flower unless the light period for day is shorter than a certain critical value. If rooted chrysanthemum cuttings are planted in winter when days are short, the result will be very small flowers on a short stem, unless special measures are taken. Artificial lighting is used to keep the plants in a vegetative state until they're ready to grow large flowers on long stems. The lighting is also used to delay the crop for a specific market. Incandescent lamps are used as they provide the spectrum of light required. They're inexpensive to install and maintain. In a night break system, the lights are turned on for a period of several hours in the middle of the night. This is in the off-peak hours, typically between 10 p.m. and 2 a.m., when electricity is metered for low-cost operation. Nev Higgs uses blackout curtains for day-length control in the long day periods of the year. Short day plants such as chrysanthemums and poinsettias have the flowering process initiated by withdrawing light. This reduces the length of the natural day. Blackout curtains must be used for this process. Shading is not sufficient. Automatic controls govern the opening and closing of the blackout curtains according to the day length required. The Brisbane City Council Plant Nursery at Manly provides shrubs and plants for parks, footpaths and reserves. Pasteurisation of potting mixtures ensures that bacteria unfavourable to plants are eliminated. Many organisms beneficial to the plants are retained. A steam and air mixture is used to pasteurise the potting mixtures at a temperature of around 60 degrees Celsius. The 48 kilowatt electric boiler can pasteurise up to 2 cubic metres of potting mixture at a time. The bins in which the mixture is placed have an inner perforated floor. This floor has an air space underneath to evenly distribute the steam and air throughout the bin of potting mix. A centrifugal fan forces the air and steam through the potting mix. Control valves are used to adjust the steam and air flow rates. The combined flow of air and steam is adjusted to give a temperature of 60 degrees Celsius. Sequeb provides a wide range of specialised services to those in the horticultural industries. If you have any problem that relates to the application of electricity to horticulture, contact our technical sales section through any of our branch offices or depots. Sequeb, electricity is our business.